Right. Today is about patterns that you may see in triangles. So first we need to talk about the different triangles that we have. So you probably remember these though from elementary school, middle school, things like that. So the first one is isosceles. What does it mean to be isosceles? Two sides are equal. Well, not only are two sides equal, but you can also have two equal angles. And the equal angles are across from the equal sides. So draw those little marks in there on your picture as well, on your index card. So the base angles, these are called the base angles, which are the ones that are equal. This angle up here at the top is called the vertex angle. So the vertex angle is different, but in isosceles triangles, the base angles are the same. Next, we have equilateral. We kind of talked about it yesterday. What does it mean to be equilateral? All sides are the same. Well, if all sides are the same, then the angles are the same. Now, in a triangle, all the angles add up to be 180. So that means each of those angles in an equilateral triangle are 60, because 60 plus 60 plus 60 makes 180. So you might want to write that in your picture. If there's not enough room, then make yourself a little note. All angles are 60 degrees. So anytime you see an equilateral triangle, just remember all those angles are 60, and that will help you find some missing pieces that you have in your picture. Now, the next one we have is a scalene triangle. And scalene, none of the lengths are the same, which means none of the angles are the same. In the real world, you see a lot of scalene triangles if you're looking at things, but you also see a good amount if you look into landscaping and architecture and things like that with isosceles and equilateral triangles. That is true. Now, it does kind of look like an upside-down ice cream cone for isosceles. That's a good observation. And they both start with an I, so that's good. All right, right triangle is the last one, and we actually have a whole unit devoted to right triangles that we do at the end of the semester. But a right triangle has one angle that measures 90 degrees. So you see that there with the box. Now, this one had an example where these other two were 45, but they don't always have to be 45. But these two angles here and here should always add up to be 90, because if this is 90, then these other two have to add up to be 90 to make 180. Okay, so any questions about the different types of triangles that you might see today or throughout the rest of your math career? Sorry about my cough. Now, make sure that you know that all the angles add up to be 180. That is a key fact. So make sure that you add up to be 180. All right, let's look at our next thing. You good? Okay. All right, write this example on your notebook paper. My little marks didn't go all the way through. They kind of left there. So if those marks are there, what kind of picture is this? It's an isosceles triangle. And in an isosceles triangle, we know that two sides are equal. So if two sides are equal, then also two angles are equal. Which two angles are equal in this one? the top two. These are our base angles. They're called base angles even if they're at the top, but they're the two equal angles. So we would just come down here and set those two equal to each other. 7x minus 8 equals 4x plus 19. Now, what would you do to solve this? Minus the 4. So if we minus 4 to 7, 7 minus 4 is 3x minus 8 equals 19. And then we would add 8. So what's 19 plus 8? And our last step, so x would equal 9. Good. Now, once you solve for x, what should you do? Plug it back in. Let's plug them back in first, and that's going to help us figure out what our missing angle is here. So what is 7 times 9 minus 8? 55. Now, just double check. Plug it back in your calculator. 4 times 9 plus 19. It's also 55. They should be the same, but remember, plugging back in is a great way to double check it. Now, we know in a triangle, all three angles need to add to be 180. So if these both are 55, 55 and 55 together make 110. So how much is our missing angle? 70. So this angle should be 70 degrees, which is going to help us find that missing variable y. So now we have a second equation to set up. 2y equals 70. So we would just divide, and y equals 35. So when you see an isosceles triangle, remember two sides are equal, which means two angles are equal. Set those angles equal, then find your missing angle. All right, draw this picture on your notebook paper. Now, this one, if you think about it, you might can solve it without having to do a whole lot of work. But let's talk about what kind of triangle it is. What kind of triangle do we have there? It's isosceles. Two sides are equal, so two angles are equal. Which two angles are equal? The bottom two, x and y. Now, I'm going to set up an equation for it. A lot of you don't have to, but I'm going to go about a little bit of the long way to get there just so you can see a visual a little bit better. So, in the triangle, we can add them all up to equal 180. But we also know that those two angles down there are equal. X is equal to y. So we can replace y with x. So in this equation, we can change that y to an x, and then we have an equation that we could set up and solve. So x plus x makes and then we would need to. And last, very good. Now, some of you, again, can do that without showing math on this one because you know that if this top angle is 80, the bottom two must equal 100 if we put them together. So if they're equal to each other, then we could divide them by 2, and we get 50 and 50 for each. So we divide that 100 by 2. All right, here is our next one that we're going to do. So write this one down. Make sure you write down all those words. Mhm. Now, if you've already written this one down, I want you to read it again. A lot of people make a mistake on this one, but also I want you to draw a picture. Okay, so read it again, draw a picture. A lot of people make a mistake on this one because they start to see two things for X and they're like, oh, well, I see these two things, I set them equal. Or I see these two things and it's talking about a triangle, so what would you do with them? Add them up to equal 180. But how many angles is it talking about? We need 3 angles, right, in a triangle, and we're only given how many? 2. Good. If you don't read it carefully, though, you might think it's just 2. So if you see a word problem, it's always a great idea to draw a picture. And this is going to help you not only with Math 2, but it'll help you with Math 3 stuff as well. So the degree measure of the vertex angle is x plus 21. That's the one that we wrote on our index card at the top. The degree measure of each base angle is 2x plus 17, which means both of these are 2x plus 17. So now we add up all 3 angles to equal 180. I guarantee there will probably be one of you in here that's going to see this on the test on Tuesday, and y'all are just going to add up those 2 to make 180, or you're going to set them equal to each other. So remember, when you're taking a test, slow it down, read it. If it's a word problem, draw a picture. So the first angle is x plus 21. The next 2 angles are 2x plus 17 and 2x plus 17. Now, add up your like terms. So we got 1x, 2x, 2x, which makes 5x. Then we have 21, 17, and 17. 55. Then we need to minus the 55. What's 180 minus 55? And then we would divide by 5, so x is 25. Now, this question said, what is the value of x? But if it asks for the angles, don't forget to do what? Plug them back in and double check them. Make sure you got them right. That's right. That is a good thing to do. All right, let's look at our index card is coming up next. So grab your second index card, perpendicular bisector theorem on the front. And then you can draw this on the front if you want to, if you don't have enough room. But the rest of those words on the back. Bless you. Okay, that's fine. Go ahead. Oh, this is interesting. Adios. Are y'all going to do the Parent Trap handshake? You never seen the Parent Trap? Oh. They don't know that they're twins. Okay, you got to watch the Parent Trap. You got Disney Plus? Okay, it's the newer one with Lindsay Lohan when she's like 10. It's okay. We're watch the handshake after notes. Okay. Perpendicular bisector theorem. That's what we're looking at right now. Now, think about those first two words. Perpendicular is the first word. What does it mean to be perpendicular? Not parallel. Yeah, it's the opposite of parallel. Those, you have two lines. What do they look like? What do the two lines look like? That's right. They intersect like a big T and they make 90 degrees. So from now on, when you see the word perpendicular, I want you guys to think 90 degrees. Okay? And that's going to help you with stuff that we not only do in Math 2, but what we also do in Math 3. Bless you. Now, the other word that's key here is bisector. What does it mean to be a bisector? Cuts it in half. Good. And another word that you can also think about with that is midpoint. Remember how we talked about midpoint and bisector were similar to each other? They're the middle point. What cuts it in half? So the perpendicular bisector theorem says if a point is on a perpendicular bisector, then it is equidistant. That's a new word. And no, I did not make it up. It's a real word. That's right. It's equidistant or the same distance away from the endpoints of the segment. So this little note here with the little star by it, it's actually explaining this picture. CD is the perpendicular bisector. You see the right angles, right? That's the perpendicular. You see that it is halfway because we have AD is equal to DB because of these little marks here. So CD is the perpendicular bisector. Point C is the same distance from A and B. So add this to your index card. Add these two marks here and here. What the perpendicular bisector theorem says is that if you have that perpendicular bisector, it's the same distance away. And then it makes a special kind of triangle here. Triangle ABC. What kind of triangle is this one? Well, not ABC is not a right triangle. Almost. Not equilateral. It's isosceles. These two sides are equal, AC and BC, but AB is not equal to those two sides because they have different markings on them. So since the two sides are equal, it's an isosceles triangle. Now, the converse is also true. So if these sides end up being equal, it can form a perpendicular bisector when we draw that line in. It'll cut that side in half and make some right angles. So that's what the converse part says. All right, let's look at a couple of examples that we're going to draw on our notebook paper and just try to draw these as best you can. You know, you don't have to make them perfect, though. Some of you get really particular about making them look exactly right, but they don't have to look exactly right. All right, so we have these two to do. This is number 4 and 5. Can y'all see those okay in the back? You can see the numbers okay? All right, I made them bigger in second period than first. Hello. Now, do these two pictures look like the index card that you just wrote? Do they have the perpendicular part? Do they have the bisector part? Yeah, so if you turn this one, it's got the same things here at the bottom. So remember the index card said, if you see a perpendicular bisector, then it is equidistant from the sides, which means this side is equal to this side. So what do we do with those two things? There you go. Set them equal to each other. And then solve for x. What would you do to get x by itself? I would also minus 6x. So what's 4x minus 6x? Negative 2x equals negative 10. That's true. You could get rid of the negatives, or you could just go ahead and divide by negative 2. So x would equal 5. And again, if it asks you for more things, you could plug it back in and double check it. All right, what should we do on question 5 here? Equal these two together. I see the perpendicular bisector, so the sides are going to be congruent because they're equidistant. So 3n minus 1 equals 5n minus 7. Now, what would you do to solve that one? Subtract 3n, so what's 5 minus 3? And then we would, that's right, add 7, so we get positive 6 equals 2n. And last step, so n is 3. There you go. A lot of times with geometry things, if they look equal, they probably are. And if I didn't give you any other information and I just gave you this picture, what would you do with the things that are there? Well, probably set them equal. There's no total there, so they probably are the same. So go with your gut when you see geometry. If they look like they're equal, they probably are equal. All right, last index card we're going to do. And then we have 2 examples that we're going to do, and then you guys will have time to work on your homework. So our last index card says angle bisector theorem. So write angle bisector theorem on the front, and then you can put everything else on the back. The picture can go either on the front or back, whichever one that you choose. Now, this is our first full week of 5 days of classes since the beginning of November. It's been like 8 weeks since we've had 5 days of classes. Or beginning of December. I think I said November. I don't think we're going to have any more snow days. I did enjoy the snow days, but oh, that was very good picture. Yeah. Make them a little straighter. It did look like a pencil. so you had a project about Calvin Coolidge, and you drew somebody different on it? Calvin Klein. Was that Mr. Lewis? Did he know it was a different person? Oh. That just reminds me of Clueless when she's, I don't know why, when she's like, well, I remember Mel Gibson accurately, and Hamlet's the one who said it instead of his, or brother said it instead of whatever. Yeah. All right, let's talk about this index card and get to the examples. So this one is our angle bisector theorem. So the key thing that we have, are y'all listening? So angle bisector theorem, right, Summer? Right? Okay. So first off, what we got to have is we got to have an angle that's bisected. So if you look over here at Q, it's split into half because we have those little marks there. So the bisector part is QS. That's the angle bisector. It's the ray that bisects the angle. And this one says if a point is on that bisector, then the point is equidistant from the sides of the angle. So I wrote in a little extra stuff here and mark this in your picture. RS, this part, is equal to SP. So anything on that bisector is going to be the same distance from the sides. And in order to make it the same, you see a 90-degree angle in these corners to make that part the same. Now, the converse of this is also true. So if we have something that's equidistant from the side, then it's also going to bisect the angle. Okay? So let's do two examples real quick, and let's see if we can figure these out. Do y'all need more time to write? Yes, no. We're still right. So remember, the converse just switches it, right? There's a lot of times where we have like these definitions or theorems, and the converse would be true. So if the original statement and converse is true, we call it a biconditional statement. All those fun terms from first unit. Yep. We're still writing. Okay, let's look at our last two examples. So draw these down. Now, they don't have to be drawn perfectly, so just close enough. It's also in Allegheny County. Okay, you're welcome. Now, do these look like the picture that's on your index card? Yeah, we got the angle bisector, we got those right angles, and these two things are labeled, the 7x and the 2x plus 25. What should we do with those two things? Equal them. Set them equal, because it said that they are equidistant from the sides, so these two parts are equal to each other. So we set these things equal to each other. And then solve it. What would you do to solve? Minus the 2x and then divide by 5. So x would equal 5. Okay, then on this one, we would set them equal to each other. Whoops, I'm writing on the picture. It doesn't like me. So 4x plus 9 equals 6x plus 3. We see that angle bisector. Those two parts are equal to each other. So we need to... And then how do we solve them? Subtract 4x. So 6 minus 4 is? And then? So 2x would equal? And then x would equal 3. That's right, we divide by 2, and then x is 3. Don't forget, you can always plug it back in to double check it and make sure that it is correct. Your homework is listed on Canvas, so now you can open up your laptops and work on that homework. Any questions, though? Anybody got any questions? Okay.